Hey everyone, it's Chaz. I'm back with another video. This is the first Java video on this channel. And in this one, we're going to be solving the very first problem on LeetCode, which is called Two Sum. Now, when I say problem number one, if you look at the list of problems on LeetCode, it is literally number one. So it's usually a good introduction. It's often the first problem that people see when they get on LeetCode, or if they're new, it may actually be the first Java problem they ever solve. So let's dive right into it. Let's read the problem, make sure we understand it. The problem says, given an array of integers called nums, something like that, and another integer labeled target, we want to return the indices of the two numbers such that they add up to target. So in this case, if I look at this, I'm looking at two numbers that add up to 9. And I could see in this array, 2 and 7 add up to 9, but I don't return the 2 and the 7. I need to return the indices. In an array, the first value of the array is index 0, the next one is 1, and so on. So the 2 is located at index 0, the 7 is located at index 1, and so we return 0, 1. And then reading the rest of the problem, it says that you may assume that each input would have exactly one solution, and you may not use the same element twice. So we're going to have two separate values, two separate indices, and we're guaranteed to get an answer. And it says we can return the answer in any order, which means that for this problem, 1, 0 would also be allowed. So we look at another example. In this case, the target is 6, and the two numbers that add up to 6 are 2 and 4. They are located at index 1 and index 2, so you return 1, 2. And another example here, there are only two values in the array, but they do add up to 6. And in this case, we're not using the same element twice because there are two separate 3s in the array, so we can use them independently. So we return 0, 1. And since they did tell us that there's exactly one solution, this situation is only going to come up when there are two values in the array. So we're not going to see an array that's like 3, 3, 7, and then the target is 10, because then there are two possible answers, and they told us there will only be one solution. Now let's take a look at the constraints. So it says nums.length is going to be between 2 and 10, including those, 2 and 10 to the 4th, including those values. So that's important because if the length of the array was, say, 1, then it would be impossible to get an answer. So we would have to code something to take that into consideration. And also, what if the array is just empty? In our case, the constraints say that the array will not be empty. In fact, it won't contain one item. It'll always contain at least two. Then it says that the value in each individual element of the array, nums of I, is going to be somewhere between negative 10 to the 9th and 10 to the 9th. And also the target value will also be between those values. And that's actually important depending on the method you use to solve this problem. Because in this case, 10 to the 9th is 1 billion, and that is less than half of the limits of the int data type in Java. So because of that, it means that we can safely add two values in the array and not overflow the limits of int. If these values in the array could go past 2 billion, then it would cause a problem if we tried to add them with each other. So speaking of adding the values together, one common way that maybe a person who's new to Java may think to solve this problem would be something known as the brute force method. So what is the brute force method? That's what happens if you just take your array. I just gave an example array here with 7 values in it and a target value of 9. And in brute force, you would just start with the first value and then try every other value in the array and just add them up and see if it's 9. So start with 1 and 4, and then that's not 9, so you check 1 plus 9, and well, that's not 9, so 1 plus 3, and 1 plus 7, 1 plus 6, and 1 plus 11, and then when none of that works, you move on to the next value in the array. So now you go to the 4, and you check. You don't have to check 4 plus 1, because you already checked 1 plus 4. So you'd actually just start at the 9 and go 4 plus 9, 4 plus 3, 4 plus 7. The problem with this is that you end up running through the array so many times because you have to check every value against every other value And so this is known as having a time complexity, or a big O, of n squared. So what do I mean by that? What I'm saying is whatever the length of your array in this case is, or whatever the size of your input data is, you can expect that the number of operations that will take place in order to solve your problem is that value squared. So maybe that's not a big deal for an array that's only size 7, but what happens if the array is the maximum here? So it says that the array can be as long as 10 to the 4th. That's 10,000 values in the array. And 10,000 squared, well, that's, wait, 100 million. 100 million. So in the worst case scenario, in that situation, you're going to perform 100 million operations just to solve this one problem. Now, that might not be a big deal on LeetCode, but if you are coding something for a large company and it's going to be seen by millions of people and they're going to use your code multiple times a day, that can be a serious problem, because as soon as one person tries to run your code, it could potentially result in 100 million operations, and in the meantime, there are millions of people waiting in line behind them to use your app. So that could be a serious problem. We're not going to deal with time complexity of O of n squared. We're going to do something else involving what is called a hash map, and that'll be done in big O of n time, which will be much smaller and much faster for large array sizes. What is this hash map method? Well, let's talk about it. So what we're going to do is we're going to go through 3 steps. For the current element in the array, we're going to check if the target minus that element is in a hash map that we're going to create. And if that value is not in the hash map, then we're going to add our current element and its index to the hash map. But if the value we're looking for is in the hash map, then we've found our answer. Now, how is this better than the brute force method? Well, in this case, instead of checking every element against every other element, you actually only have to check each element once. So that's big O of n time, way faster than n squared for large arrays. And then, well, we are adding an additional step, right? We have to search a hash map. So how long does that take? Well, as it turns out, searching a hash map, searching for its keys, is done in constant time. So regardless of your conditions, you should expect your search to take the same amount of time every time you do it. So overall, this will be way faster than your brute force method. So we've described the algorithm. Let's see what it looks like, visually. Put the instructions up on top. I have my array here, and just to make things easier to visualize, I'm actually going to put the indexes, or the indices, of each value in the array right above them in yellow. So that value 1 is located at index 0 of the array, and then the 4 is located at index 1 until we reach the end of the array, which is index 6, and that tells me that we have an array of size 7. The length of this array is 7 elements. Now it says we need a hash map, so we'll create a hash map. A hash map always stores pairs of values. There will be a key and a value. And in our case, we're going to put the element of the array itself, so the number in the array is going to be assigned the key, and the index of that number is going to be stored as the value in the hash map. And we're doing it this way because we're trying to find the numbers themselves in the hash map. When we need to search a hash map, it is much faster to search through the keys. That's what takes constant time. So since we're searching for the numbers themselves in the array, not the indices, we're going to put the numbers themselves as the keys. And then since we're returning the index in the final answer to this method, we can store the indices as values, so that this way when we search for a key, it'll return the value, which is the index that we need. And then it says we need to check for target minus element. So let's just keep that in a box right here. For the current element, let's start at the very beginning, index 0, which is the number 1. We need to check target minus element, which is 9 minus 1. 9 minus 1 is 8. Let's put that in the box. And then we're going to check in the hash map. So what we're asking is, looking at these keys, is there an 8 in the hash map? Now, obviously, at this point, we haven't done anything with our hash map, so there's nothing in it. So obviously there is no 8. So because we don't have an 8, we're going to add the element that we checked, which was the number 1, as a key, and we're going to add the index of that number, which is index 0. We're going to put those into the hash map. So the 1 will be a key and the 0 will be a value. Then we move to the next value in the hash map. That'll be a 4, which is at index 1. Target minus element is 9 minus 4. So we are now searching for a 5 in our hash map. So we ask, is there a 5? The answer is no. So I'm going to add 4 and 1 to my hash map with 4 as the key and its index 1 as the value. And then we'll keep doing this. So we check the 9. 9 minus 9 is 0. Search for a 0. We're asking, is there a 0 key? So we're not talking about this 0 in the values. We're only searching the keys. So is there a key 0? No, there is not. So we add the 9 as a key and we add its index 2 as a value. Right there. And now we move to the next one, which is the number 3, which is at index 3. 9 minus 3 is 6. Is there a 6 in this hash map? There is no key 6. So we'll add 3 and 3 to our hash map. Next value is a 7, which is located at index 4. 9 minus 7 is 2. Is there a 2 in my hash map? And remember, I'm searching the keys. There is no key 2. So we add 7 and 4 to our hash map. Now we get to index 5, which is the number 6. 9 minus 6 is 3. Is there a 3 in my hash map? Yes, there is. We found the key 3, and it goes with the value 3. So we were checking the value 6 at index 5. We found the 3 at index 3. We found our answer. So let's look at the question now and see what we actually have to do with this information. It's said to return the indices of the two numbers. So we're not returning the 3 and the 6. 3 plus 6 equals 9. We're not returning 3 and 6. We're returning the indices. We're returning the index of those two numbers. So we're returning the 3 and the 5. And since you can return the answer in any order, you can do 3, 5, or you can do 5, 3. So that's how we do it visually. Now let's actually code it. So on LeetCode, they gave us a class and they gave us the start of the method, and it's usually important to take a look at this. Like, for example, we were trying to return 2 values. Usually in a method, you can't return 2 values unless you use an array. So in this case, we are using an array of integers, an array of ints, so we can return 2 values. So usually the first thing I do on LeetCode when I'm trying to solve a problem is I'll actually just create this data type. So I'll do int array and I'll name it answer equals new int of size 2. And then I'll even just return it right away, return answer. This way my code immediately runs. So when I want to start doing tests early on, I don't have to worry about a missing return statement. But actually, I'm not going to do it like this. What I'm going to do is eventually I'm going to return the new int array directly. I'm not going to store it first. So don't worry about what all this says just yet. This is what we're going to do at the end. So let's start by creating our hash map. So I have here hash map and then angle brackets, integer, comma, integer. That represents an integer key and an integer value. And you may have noticed if you haven't used a hash map before that I'm not using int, comma, int. I'm actually writing out integer, integer with capital I's. It's because with a hash map or a linked list or an array list or a queue or a stack, you have to use the wrapper class that goes with that primitive data type. So you wouldn't say int, comma, int. You would actually use its wrapper class, which is integer with a capital I. And that goes for all of the primitive data types. So if I wanted to create a hash map with doubles, I would use double with a capital D. If I wanted to store a char, I would use character with a capital C. And you may have noticed that string is not in here. And that's because the string class doesn't require a wrapper class. If you've noticed, whenever you use a string, string already has a capital S. So hash maps work perfectly fine with strings. You don't need to wrap it. You don't need to put it in a wrapper class. All right, so we have our hash map. We said we needed to check each element of the array. We're going to check each element once. So to do that, we're going to use a for loop. Here is our for loop. For those who haven't seen a for loop before, I'll just break it down really quick. What I did was I just created an integer, named it I. We're going to start that at 0, and we're going to do this loop a certain number of times, and the number of times depends on whether this statement here is true or false. So this loop will run until I is no longer less than nums.length. As long as I is less than nums.length, which is the length of the array nums. So in the example we gave earlier, the nums array had a length of 7. So this would run until I is no longer less than 7. And how do we make I change? Well, that's the third part. I++ just means we increment the I, or we increase it by 1 every time we reach the end of the code that's inside this for loop. And just to go back real quick, I'm using less than the length of nums and not less than or equal to, because in this case, like in our example before, the array had a length of 7. So we don't want I to actually be 7, because if you remember, an array starts at index 0. So an array of length 7, the last value has an index of 6, not 7. So we want this to go 0, 1, 2, 3, 4, 5, 6, and stop. We don't want I to become equal to 7, because then it would go out of bounds, because there is no index 7 for an array that has a length of 7. It stops at 6. So we need to keep track of the target minus the element, like we were showing in the example. So I have here an int that I named complement, and we're setting that equal to target minus nums at index I. So the way I'm thinking of it, I'm calling it the complement, because I'm thinking like if the target is 9 and we're checking the value 1, it's like we're saying that 8 is the complement of 1. Or in other words, 8 is the number that I need to add to 1 in order to reach my target of 9. All right, now I'm about to put a few lines of code on here at the same time, but don't worry, we're going to go through them one at a time. So first of all, we'll look at line 7. I'm saying if map.contains key complement. So first of all, map. If I go up to line 3, I didn't mention this earlier, but when I created my hash map, I had to give it a name, and I gave it the name map. You can see that in pink. So when I say if map, I'm referring to that hash map. And what I'm asking is, does this hash map contain the key which is equal to complement? So like in this example here, the complement was 8. So I'm asking, is there an 8? And in my case, I know in the example, we talked about what we do if it's false, what we do if it's not there. But what I did with my code was first I showed what to do if it actually is there. So if map.contains key complement is true, then I'm going to immediately return my answer. So I'm going to return a new int array. It should be 2 values. What are my 2 values? Well, let's look back at the example. It was 3 and 6 that added up to 9. So the first value that I'm returning, it says map.get complement. So in this example here, the complement was 3 right there. And so what I'm saying is take your map, your hash map, and we're going to get the key, which is a 3. So we'll search this. And actually, even though I'm showing a moving arrow with a hash map, it doesn't actually have to run through the elements to find something. It can do this in constant time. And what will happen in this case is when I get the complement, when it finds this key, it's not going to give me the key value itself. It's going to return the value that goes with that key. So in this case, it just happens to also be 3. So my get complement will be 3. And then my other value, it says comma I. And I is just the location of the value we were checking. So in this case, we were checking the 6. 6 is located at index 5, and so we return 5. And in this case, our final answer would be 3, 5. And if you wanted to, you could switch these two around and do, instead of map.get complement first, you can put I first and do I, map.get complement, and your code would still return the correct answer. Now, that's what we do if we actually do find the key in the hash map. That's what we do if it's true. What do we do if we can't find the key? Well, that's what the else statement is for. What do we do if the key is not there? Well, it says take our map and we're going to put something into it. What are we putting in? That'll be nums of I and I. So what we say is there an 8? The answer is no. So we're going to put nums of I, so the value at index I. So in my example here, I'm checking the value 1, which is at index 0. So I'm going to put the number 1 as the key. and I'm going to put its index 0 as its value. So that's what it'll look like. Now at this point, our code would be finished, but there's just one problem. The way I wrote this, if you try to run this code, it won't compile. You'll get an error, and the error will be a missing return statement. And that's because even though we're told by LeetCode that there's guaranteed to be an answer, what if there isn't an answer? If there is no answer to the problem, then your for loop is going to finish. And if it finishes, then that means you never hit the return statement. So as far as Java is concerned, there is no return statement. So we need to add a return statement outside of the for loop, just in case the for loop fails to find an answer. So the way you can do that, really the easiest way to do it is just to add a return statement outside the for loop, just right at the end of your code. We'll just return a new int array, and you can just put any two numbers in there. What most people do is if they're trying to show that the result of this method is that there is no result, we're unable to determine an answer, sometimes you just return -1. So in my case, like here, you would just return a new int array with the values -1 and -1, but it actually doesn't matter what numbers you use. You can even return an empty array. So I actually did not do it this way. I did it a little differently. Instead of returning a meaningless array, I added a throw, which was throw new illegal argument exception, and I gave it some custom text which just says no two sum solution. So if for whatever reason this for loop completes and it never finds an answer, then my code would just throw an illegal argument exception and say that there is no solution. And this works just as well as a return statement. Now, if you have used exceptions before in methods, you may be wondering, well, shouldn't I put a throws declaration at the start of my method, throws illegal argument exception? Well, in this case, no. And I'm not going to pretend to be an expert, but basically what it comes down to is that this exception on line 13 is what is known as an unchecked exception. So I don't have to declare it at the start. So what will happen is if your method is specifically checking for an exception, like it's testing, like trying to get an exception, we're testing to see if an exception will happen, you need to declare that at the start of your method so that when other classes try to call your method, they have a warning that, hey, this might throw an exception. And without that warning, first of all, the code won't compile. But second of all, it could, if it did compile, it would cause a serious issue because that class may not be expecting an exception and all of a sudden it gets one and then your program crashes. So in this case, because this is an unchecked exception, you don't have to declare it at the start of the method. So you don't actually even have to do this. You can just return an array with any two values in it if the for loop completes, and we know the for loop won't complete because LeetCode told us there's guaranteed to be an answer. So that's just about it. So here's our full code. That's it for this video. I'm going to go through some more LeetCode problems. We'll go through some more easy ones, and then as we go through more of the data structures and the algorithms, we'll start to move up to the mediums. For some of the more advanced concepts, I bought some toys to help us explain. I got some stuff over here. We're going all out. So that's it for this video. I will see you next time. Oh, and like, subscribe, share, comment, Bye.